Hey everyone, hope you all are doing good. Good morning, good noon, and good evening to all who all are joining us globally. I am Partharu, Event and Program Manager for Microsoft Reactor Bangalore. And yes, welcome to the yet another episode of MVP Connect. And today we have an exciting session on AI. AI. AI is like continuously on all channels now and these days. So I before we start, let's go through our code of conduct. We are all here to learn together. So please be respectful of other people's views. Understanding of differences, being kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the chat section and we'll pick it up from there. And now let's not delay it anymore. I would like to bring in a speaker for today's session. I'd like to bring in Ayyanar. Hey, hi Ayyanar, how you doing?
I'm doing good. How are you doing, Path?
I'm good. I'm like Ayyanar is gonna tell the audience like welcome to the world of AI.
Welcome to the world of AI, particularly generative AI.
Something very much interesting these days. Correct me if I'm wrong.
It's an exciting space, and a lot of business
Yes.
people are figuring out what are the business value it does brings them, and it's really exciting space.
Wow, that's great. So what are we gonna learn today, Ayyanar?
Today we are going to learn about how you use the Azure OpenAI to converse with your data. See, the generative AI democratized with the advent of the ChatGPT, thanks to the OpenAI
Right.
community, and where it lacks is connect with your own data and work the data and bring a value out of it. Today we are going to do the demo and what are the components and services stitched together to build a solution around it. And 50% demo. This session is completely going around little bit about theoretical and 50% we are planning to touch on the demo so people can go take away and test it in their environment.
Wow, great. So, Ayana, a quick introduction about you to our folks. I would like to tell them. Ayana, he has like around 18 plus years of IT experience and he's passionate about learning and sharing knowledge on Azure, Kubernetes, DevOps, machine learning, well architected framework in the cloud. And he actively contributes to the Cloudnloud Tech community, which helps the cancer childhood. That's great, Aina. Thank you for doing that. And he has like, wow, what to say, like 50 plus technical certifications in Azure, IBM Cloud, CKAD, etc. And yes, Ainar, uh, I would not rather delay anymore. And please, the floor is all yours, and let's begin the session.
Thanks for the kind introduction. Okay, let's get into
Thank
the
you.
session, today's session. I'll go on my, stop my camera and I will put on my slides so
Yeah.
people can do it. Okay, you are present, share screen, good. And let's come down to this one. Okay, it's me, Ayyanar Jeyakrishnan, and thanks for the Reactor team to provide this opportunity. It's a wonderful platform to share the knowledge and build a growing community. And it's you can connect with me on the LinkedIn. I'm happy to share more. If you have any further questions after the session, also happy to take few questions on the LinkedIn. Okay, thank you. Today's agenda, we're going to talk about what is Azure OpenAI and its features, and what is cognitive search, and what is a new services introduced in the cognitive search, which is related to the generative AI. And we talk about retrieval augmented generation, what about RAG. And we are planning to have a two demo. After the first uh, topic, I'll have one demo so that we guys can get a look and feel of it. Then we have a final demo where we can have a end-to-end applications, build end-to-end chat applications connecting with your own data. Okay, let's jump into this one. And Azure OpenAI has a different models generative AI models. Okay, if you want, I think everybody in this call who joined would have had experience about a generative model. In a simple term, you train the data. You, in a simple term, you train the model with a large amount of the data, and you will get a out using that model. You get a novel output. Okay, so if you are, it can be a text, or it can be a image, or it can be a voice. Okay, and how it powered? It's all powered with the transformer architecture, where the transformer architecture, if you want to give a one liner, it's on 2017. There's a paper released. Attention is all you need. The main objective of the paper is to do the translation, the efficient translation, but that model architecture is highly scalable and have a parallel processing, and it has a context understanding, positioning. So they started using the transformer model for all the use cases. And from the Azure OpenAI, the Chat GPT, whatever the Chat GPT which we are using, that is also transformer based architecture, which is a decoder based model. Transformer has a two part, one is an encoder and decoder, but Chat GPT is powered by the decoder and have a lot of powerful fine tuning done behind that. We will slowly touch upon how it was done also. So embedding. So what is embedding? Where the embedding is nothing but if you are having a large amount of the uh, text data. Take an example of text data. You take the data, convert that into the vector, uh, and represent to the large language model. And Azure OpenAI, we have a two different embedding. What we call it as ADA. They in ADA itself they have version 1 and version 2. They came up with a new version because lot of there's a model improvement happened on the improving the context length. We will touch upon what is context length also. So that's where there's a new embedding model came to the picture. And then text generation, it can be a chat, or it can be a any kind of text generation. There are four models available: GPT-4 and GPT-4 32K. 32K is nothing but a context window. So let's say you want to summarize the data to of summarize your text input to the less amount of lines. Let's say if you have a 100 pages which has 30K tokens, you want to summarize into two paragraph where you can easily read. So using your GPT-4 32K, you can keep it in a context window, those information, ask them to summarize. Okay, and previously there is a limitation, the previous model like only 16K, so you cannot do that one. Now with the GPT-4, you can use a 32K. Then we have a DALI E. So this is text to image. Like you can create a person who flying over the ocean. So it can give you the novel images. Okay. Then this last one is a whisper. For the first three, we are going to do some demo. The last one is a whisper. It is to speech to text. Okay, if you have any audio wave file or MP3 file, it will extract the information. And so this is in a preview mode. It is not we don't have much demo today, but we will touch upon other three models little bit demo. So embedding 101. So very important to touch upon the basics. What is embedding? What is tokenization? So with a simple term, we can call in a word, I love my country is a four word, but that can be tokenized. The dot also can be tokenized. So in overall, if you take 100 words line, it can be, we can say we will have a if you have a 75 word line, it can be almost like 100 tokens. Okay, so here you see we have a dog, cat, fruit, banana. So we are ranking them on the based on the dictionary lexicon. Then we converting the word to vector, which is converting the vector, that's using a wet vector, and storing into the and then we are finding a similarity, semantic search. So you can see cosine similarity, the dog and cat be in the same place. uh, but at the same time, if you are clustering, the dog and cat will be the same near to that, and it will be the fruit and banana. So clustering, if you it's a basic thing is it will be using the Euclidean distance to identify what is a nearby vector information. So this is a very basic thing. This is about the word. Let's just zoom it a bit and go for a sentence. So the reason I want to touch upon the embedding in a UI in a visual manner is this is very, very fundamental to understand the large language model. Okay. So this is a corpus. I say I love playing football. Football is my favorite sport, and I love watching football matches. And soccer is worldwide. And I can also give additional text like a basketball is an exciting game. So what does it do is it first convert the vocabulary and identify what are they, and it will do the give the vector information, and it is positioning into the large vector, and you can see the basketball is an exciting game, which is a completely different from football. Is my favorite sport. So the distance between them is different. If you even if you say cosine similarity, it will be very much okay. If you say I love playing football and football is my favorite sport, both the cosine similarity is very nearby. Okay, so that is the basic of the embedding. Okay, um, and we will zoom in bit uh, while we are touch base on the cognitive search, how it power of using a multiple indexed, how we can store in the index and use it for our large language model. Let me go to the small demo. We will use a GPT model and the chat model and using an image, how to build an image using a DALI. This is, I'm going to my notebook. So I installed OpenAI. So there is a multiple way to do it. You can always go to your okay Azure OpenAI, and you already have a visual tool to do this one. So I created some. I created this. I can come down here, and I can go to the OpenAI Studio to do this task in a UI manner. But I plan to show it on the uh, in the programming manner. I'm going to use a Python to do this one. So you can use a chat playground. You can use a completion playground. So chat playground is it is a role play like in a chat GPT how intuitive it is. You are giving an input as an assistant of the chat GPT is giving you the output. But at the same time, you can do the completion also, and you can create a novel images using a DALI also. So this you can do it from the UI also. At the same time, I'm going to show it in a programming manner. I'm storing all my config information. I'm using a Azure ML Studio and keeping all my configuration. So okay, I don't want to touch this. So I'm installing the OpenAI library. So it will take the uh, endpoint and other information from the config. So the deployment, this is very important. Okay, the deployment is nothing but what model I'm going to use. So I'm going to use this Reactor demo GPT. I'm powering with GPT 3.5 Turbo. Okay, so you can use any of the model. Okay, and I'm what am I trying to do is I'm using this deployment ID and I'm giving the information. I love LeBron James. If you want, I can say I love Virat Kohli. If I type this information, okay, I think I need to run this again. The endpoint information. Okay, run. So if I run this, Reactor demo. Sorry for this some glitch on the demo. Is it opening a key? Okay, I think I need to run the other file. Yes. Yeah, if you run this is I'm using a completion chat completion. I given the output, your helpful assistant. Okay, and I'm giving the user is giving this Azure OpenAI customer managed keys, support customer managed keys, and the content says customer managed keys are supported by the AI, and it is asking to completion. Do the other Azure AI service support this too? And what is it doing is it's completion. It is giving you how many tokens it is. What is a prompt token? This is a prompt token we are given, and what is a prediction token? Okay, it is giving you the output. The completion model is giving you output. Okay, then I'm trying to create the image. So I mentioned like uh, I give it the prompt here. There's a prompt panda doing surfing. That is the information I give, and it store the image. If I go here, look at this. This is a normal image. You can change the dimension of the image. Okay, and this is powered by the Dolly model. Okay, so this is a small thing I want to touch upon. What is completion, chat, and then creating a Dolly. Let's go to the next one. But the power of the chat GPT is now comes with a lot of technology they use. They use a content filtering, and it will the content filtering can be like a it will avoid any hate or sexual violence and harm content, and it will be rated at whatever the it will rate as low, medium, or high. Then prompt engineering. Okay, you can give us a small example in a chat and ask them to predict the same. It can be a zero shot prompt or few shot prompt. You can have a hundred. You can have a 15K word token, 15K token page summary, and you can have a sample question and answers with the and you can say can you create more question out of it. It will create a more question of it. It's the example of the few shot prompt engineering. And abuse monitoring. Okay, so it will ensure that you guys anybody is giving the wrong prompt information, and it will do the uh, instant. It will make sure that the output is not abused. Okay, and they have a lot of red teaming behind it. So people, you can see whenever you are using a ChatGPT, will give a thumbs up and thumbs down. What they will take this a feedback, human feedback loop, and then they retrain the model, make sure it is helpful and that doesn't has any harmful content. Okay, then very important feature recently released is bring your own data. Okay, and you can do it when a UI also, but we are going to do see it in a program manner today. Okay, so bring your own data. We are using a technique called Retrieval augmented generation. I'll walk you through the life cycle or the step by step what is called Retrieval augmented generation. Also, there's a powerful feature by the OpenAI. Let's come to the next service which we want to talk about is a cognitive search. Okay, anybody worked on any search product like Elastic Search? Okay, and cognitive search is almost similar the thing. Okay, so you can have a no JSON document stored in a cognitive search. It give you the powerful feature like semantic search or full text search keywords. Let's take with the basic thing. You have a content in a database, but you want a few columns need to be retrieved as a JSON output for your front end application. What you can do is you can index the data. The data, it can be any database. It can be a document also. It can be a flat file also. Or the classic example is something the JSON file which come from the IoT also. We can retrieve the data. You can take the data and keep it in a cognitive search, index it and keep it in a cognitive search, and it give you the powerful querying. Okay, so you can have a very simple query like a keyword search. Okay, um, we can example like a cricket. It will give you the information in the whole documents. It will index the information and say this is the play JSON file contains the cricket. It is just a giving you the keyword search. At the same time, you can give a full text search. You can give a whole line. It will understand the semantic interrelationship and give you the output. Okay, and recently they announced it will support the vector search also. The advantage, people can always can ask what is a Why do we need a vector search? Because it already have a text search and it has a semantic search to identify the meaning. Why do we need a vector search? Vector is not only for the text. Vector, it can be any object. Okay. Um, this is what it can be any object. It can be audio, it can be video, or it can be text or image. uh, so it will convert that in using an embedding model. It will convert those data and s- create a vector output and store it in the cognitive search. Whenever people want to query that information, again that input where text will be, or text or object will be converted into the same embedding model, and search it in the cognitive search and identify using a KNN, okay, and find out what is the relevant information and give you a result. This is what the vector search is. Okay, so the vector search is recently announced. Okay, this is the flow. You can use the vector embedding using your model like ADA, and you can add a vector field to the index. We can create a multiple index. You can have a composite index, one for image, one for audio, and when you're querying, you can write a program in such a way to query both. And when you query the vector data using API or your UI, it will use the same transformer model and take the vector representation of that output of your input you had given, and search it in a cognitive search and give you the result back to the UI. This is about the cognitive vector search. And why are we talking about cognitive vector search? Okay, large language model like a big foundation model like we have seen GPT 3.5, GPT 4 will not solve all the problem, because yes, it trained with the 2 trillion tokens, but we have a lot of use cases within enterprise, okay, or which the data is not trained upon. Okay, what will happen is if that is it, rather than giving I don't know, I don't have the output, it often confidently give you the wrong information, which we call it, I don't say confidently give a wrong information, confidently it will generate the tokens in which we call it as a hallucination, with a big problem. Okay, and of course, a large language model, which we call it as a foundation model, it is not a subject matter expert, okay, where you will have, let's say, if you want to have your model to do powerful Q&A, for example, your travel related chatbot, then you need to train that model, which we call it as a fine tune, which has a different technique, okay. You can say fine tune the whole model, provided it is an open model. Um, or fine tune with the LoRa. Recently, Azure also announced you can fine tune your model also, and it give you the output, but it will not give you the information where this output comes up with. Okay, because these are all major problem where any enterprise who want to adapt the large language model for your use case, they always want to make sure the results are very concrete, and it should not hallucinate, and it need to solve their own problem. Let's say if I'm building a chat application, it need to focus with the particular context data. So we need to fine tune the model with that context continuous data, and at the back end we need to monitor the model, make sure the output it is giving, it always has a relevance, the governance in place, like where it is taken from. Okay, that's a fact check need to be done. These are the three major problem and where we have to address. Okay, that is where this solution like retrieval augmented generation is coming into the picture. So imagine you have a big database. Let's say you have a Confluence database or any big your knowledge base. Let's say wiki, internal wiki, and if you want that to be available as a from your front end chat application, and okay, so how do you do it? This you cannot take the data and put it on the internet because it's your proprietary knowledge base. So how you have to do this one is there are two part in the retrieval augmented generation. One is the ingestion part, another one is a retrieval part. So ingestion part, how does it do? It take the data and it will chunk the data. Why? Because the every model has a context length issues, okay, context length limitation, okay. So you cannot do the complete embedding, it will become a challenge. So you have to chunk the data, take say example 512 tokens or different based on your use case. You chunk the data and use the embedding model, convert into the vector and store into the Azure Cognitive Search. So this is an ingestion lifecycle. Hope this would be clear. The next one is where the retrieval comes into the picture. The retrieval comes the moment user given an input. Let's take an example. We have recently concluded the Asia World Cup, Asia Cup, where India won the match. Okay, if you go and ask the ChatGPT, it will not give you who won the Asia Cup 2023 because there is a knowledge cutoff. And if it is giving output, it will give you the output from the old information. It will not give you the latest information. Okay, so imagine I have taken the data from the website and given the complete information about all the matches and converted into the PDF. What I'm doing is I chunk the data, use the embedding model, and convert into the vector and store into the cognitive search. In a user input, I can ask how many centuries Virat Kohli scored in this Asia Cup 2023. What will happen? It take that input and again it will use the embedding model, which is a third step. It will convert into the vector and it will go to the cognitive search and it will have all the vector element information. It's okay, and it'll give you the output. Say that this Virat Kohli, how many century it won. Then it will give you the output saying that he scored against. He scored a century, 1 century, or whatever the information. It give you the relevant information, and that will be used as an input to your text generation, like a chat GPT. Like it can, we are using a GPT 3.5 or GPT. Okay. So it will give you the information about how many century you have given. That is your user query, and it retrieve the document on which match, how much score he made, and what is the status of that match. It will give the relevant document, and it give you the user information. It give you the story or output in a meaningful manner. Okay, so Virat Kohli scored 1 century against so and so game. So it give you the I say readable output generation, and the text generation was given to it. That is the power of the retrieval augmented generation. I've given you the example of the sports because it can be easily correlated. At the same time, you can apply the same thing in enterprise for your use case also. Take an example of the wiki because wikis keep update. Everybody will be updating the wiki across the organization. And if you have a institute chat window, what you can do is you can always type for give a best practice or top 10 best practice of the Java. So rather than going to the internet and getting the information, it will go to the internal document and give you what are the best practices. Okay? Let's go to the next one. This is a third I say tool I want to discuss. We touched upon what is OpenAI and models along in it. Then we touched upon the cognitive search. The third one is a LangChain. This is a popular open source framework, which is I would call as a prompt framework, which can stitch together for developing a powerful large language model application. I say generative AI application, I would say. So it has a multiple components. Let's start with a very basic thing, model. So you can you can use any SDK, Node.js and Python, I think so. We are going to use Python as an example. So we can use a multiple models. Say you can use a Turbo 3.5 for one model and GPT-4 for one model, but you can use it under the same program. Okay, and prompt is a template. Like I give an example. Indian cricketer, and you can have a template score this century. So whoever scored the century, that can be variabilized. Okay, so the template. Okay, then you can parse that output and give us an input to the next chain. Okay, which you can be a large language model, different large language models chain, or it can be a sequential chain, or it can be QA or summarization. You can summarize it and then feed into the QA. So you can do multiple things via chains. And connect to the indexes. Okay, it can be your open source index like a files, or it can be a vector database store like a cognitive search. If you have a simple library, you can use it, which connect from the lang chain and do this one. And you can do the document loader, which can be PDF file. Let's say you can have a PDF file or CSV file. It can load those files. You no need to use any tool to convert that into the uh, represent to the embedding model, which can be done via lang chain itself. Then memory is very important to have a conversation, a chat application to understand the whole context on replying back. Okay, and you can have a vector stored by backed memory where it will live within your context, where you can keep on updating your vector store, and it will be you can use within the lang chain. And agent is nothing but a zero sat. It's a React where it has a sequential of information. You can use the tools, external tools like you connect to the Google search and give you the output. So like nothing but a uh, one additional Python program and act as an execution of the steps defined in the agents. Okay. So this is a very powerful tool. Why are we talking about this tool now? Let's take an example. I have a PDF document. I want that chat to the PDF document. I want to ask a question. Okay, let's say the PDF document is 800 pages. Rather than going and reading whole document, I can create a nice UI and upload the PDF. And backend there is a application built out of LangChain where I can ask a question out of it. The same steps which we put it in a rack, I mapped into the small code. We will deep dive into the full code, but this is small code. Here I'm using a document loader, which is a PDF document. And what does it do? It will split and store the document as a data. Okay, then the next step is it will use the embedding model and store into the vectors database. Then I'm giving a question, and that time it is connecting to the vector database and giving the question and getting the additional context. So here it is a hybrid search. It can do the similarity search also. If I say you make sure that it is doing the vector search, I need to use additional flag. So if you give a hybrid search, it will do the ranking between themselves, whichever is giving a better output. It will take that information. Then this is where the prompt, it will chain together the large language model and the retriever from the vector store, and it you give your question also as an template, then it give you the output. Okay, so this is a step we have seen in a rack, and so it's a small code. I was it's a small snippet of the code I'm showing. We can go deep dive into the full use case. So this one is a use case I'm taken. It's a demo time. 1 minute. Let me check whether it is fully done. Okay, I have it. So I will go to this document. Okay, so here, this is a small chat application. It is with the enterprise data. If I go and ask who won the last football World Cup, it will not give an output because this one will give you the output of only the, okay, just warming up for the first time. See, I don't have information about the winner because nobody is documenting in your wiki or something who won the World Cup. But this one, we are taken the data. I will show you the data here, what data we were using. Okay, so I taken the data from, so where is this? Okay, here it is. This is the data I'm using. If you go to the data, these are the 5 document we are using. Okay, it's a PDF document. I can download it and show you. So I downloaded this document. So this is the benefits plan and benefit package of the Northwind they have employee insurance company. The employees are taking the what all the cost comparison between. They have a different plans in the document. We have different information. If we go to the same thing, that is data. Okay, health plus this one document. Downloading this. So it will have all the information. Okay, this is a PDF file which we are talking about. It is 109 pages. And what we are trying to do is we are loading all the PDF file into the vector database and try to query that using our large language model. And it will make sure that the output is only coming from the data which we are in a vectors. Okay, so if you look at this one, we have created the resource. We created an app service plan for this UI, and we are using a form recognition tool from the Azure to take the form and convert into the word and writing to the and then writing to the cognitive search. Okay, so I am. You can see the PDF file which is using. Okay, it taken the PDF file and it is written to the blog, and then it is converting that particular it taken page by page and uploaded to the blog, which is a storage which he has created as part of the stack, and it is trying to do the indexing. You can see it will do the indexing. Okay, it will is taking the batch by batch and storing to the converting into the embedding and storing into the vector search. Okay, so let me go to the vector search now. Come to the vector search. Where is the vector search? This is the cognitive search. So you can see this is a cognitive search which is created. This is an endpoint. I can see knowledge center and semantic search preview. It will give you the information in the right region, right? Yes. Indexer, it will give you the how much document in the indexes. We can see how many documents. See, we are using the document of 568 information. Okay, so this document is 15 GB. So currently we are storing into the we are storing that embedding output into this vector database. Okay. So if you look at our life cycle in this, okay, this is the life cycle we're talking about, right? We've taken the data, use the embedding model, right to the cognitive search. Okay. The next one, we are giving the input here. What is the company name giving health insurance? So the company name providing health insurance is Northwind, and this is the option. This is the citation it is giving. Okay, when you give this input, what does it happen is it will use the embedding model and go to the cognitive search, identify the relevant information, and then give that information along with our query to the text generation model as an aim prompt. Then it give you the output. Let's say I give, does it cover dental? It is slow because we are taking this option. This company. Yes, okay. Insurance plan, specifically health plus plan, provide a coverage of the dental service. So you can see the value, how it is, we connected to with our enterprise data, and it is giving output with the context, with the citation information also. Okay, what else I want to show? So that's what this chat, the context is at the back end. How this service is created, I will want you to walk through. If anybody want to try yourself, go to this GitHub link. Okay, and you can use your own code space rather than doing on your environment. You can go to the code space and run ACD deploy or ACD up, which will deploy all the resources. How it deploys while the code space is using this information, dev.container, where it will install all your dependencies, CLI, and Python tool, and everything will be using whatever the .dev container file is there. It will be there. It will use this infrastructure to provision your service, and then you inside this you have a data which we are using it. You can replace the data if you want to try something different. Then this is where it is using an infra is where all the thing we are using a bicep. It is creating the resource. First it is creating the resource group, then it is creating a deployment. As we have given a demo, right? The deployment is where we are selecting the model we want to do it. I'll give you this example. So this is what it is created. Okay, inside that you have a model deployment. Sorry, in the open, yeah, sorry, it is created the deployment. This is where the deployment is there. It is created the embedding model. Okay, so it will make, okay, one second. This service will create the relevant resources. It will use the embedding model, whatever the model name you're giving, everything will be here. So this is where the parameter is. All it's the biceps parameter is there. Okay, it will create all the resources using the bicep, and that's all. Once use the ACD deploy, it will deploy all the relevant services where we can do this, and it at the end it will come with the UI where you can the deployment backend will be there. You can use this URL to do this testing. So that's a quick demo I want to show. I can speak on this particular code itself for a long time, but in interest of time to ask more questions from the participants, I leave the session back to the Paru. Okay, Paru. The, uh, that's all the demo from my side. Yeah, this is it really is a bicep. Are you there?
Yes, Anar, I'm here.
Yeah, yeah, sure. Thank you.
Yep. So, do you have any questions? Please do ask us the questions quickly. Please drop our questions in the chat section and we can pick it up from there.
Yes. Sorry, I was showing the wrong screen. You got any questions here?
No, we haven't received any questions yet today. Hmm, yep. Any questions? Final call to ask the questions. Please drop all your questions in the chat section and I could find them there. Any questions? Okay, so I have like few links dropped in the chat section, which can take your learning further. So
Yes.
explore
I
OpenAI and Azure fundamentals. Yes, Ayyanar.
Yeah, I can do a quick recap. I have given the small walkthrough because I don't want to do the knowledge them and cover everything. So very important thing you need to start with is, as you mentioned, you can use those link to start with the Azure AI fundamentals. And if you guys are watching this video and want to ask more questions, you can always pass on the comment there, or you can connect with me on LinkedIn. I'm happy to share more links and more education content from there. Okay. So hope this session would have given you the understanding of what is OpenAI, what are the features about it, what is cognitive search, and what is a few new service, new feature like vector search, and why do we need it, and what is the problem with the existing large language model foundation model, and how does a retrieval augmented generation is helping it, and what is the role of cognitive search in that particular in that framework. Then what is LangChain, which is a powerful tool which is powering the chat-based application or a large language model application. Then we have done a demo where we have connected with UI, uh, parse the PDF document and connected with this. You can be a document, can be anything. You can give a URL also, and you can use a LangChain a dog retriever to read that URL also for you, and it will automatically do the split. That is a parameter you need to tune, like a 512 or 1024, how you want to split it. It will split the document, and whatever the embedding model I used, it take that information, whatever the vector store you are defining in your LangChain, it will store into the vector search, and then
Yep.
it can create a prompt template. So it is a complete flow. You can do it along with your enterprise use case.
So there is one question I would like to bring it up on screen.
Yeah.
So what are the key benefits of integrating OpenAI's conversational AI capabilities with enterprise data through cognitive search?
Okay. So you're asking a use case or benefits? There are two things, right? The use case I have talked about it. It can be your wiki or it can be your internal data source. Okay. I can give you one classic example. Okay. Uh, let's say you have a ticketing system. You're in big enterprise. You have a ticketing system. Okay. You may using a different ticketing system. Okay. And imagine you have two servers, okay, which is going down frequently for the last 10 to 15 years. Okay, each one have a different reason. Okay, and you storing everything in your ticketing system. Somebody may be using a front end, somebody application user, somebody may be a programmer, somebody may be infrastructure manager. You have a different tool. What you can do is you can take all those data, index the data, and you can retrieve the data and store into your vector database. Okay, and build a UI like this, and ask, can you give a summary about this server and lineage about when the server, what all the time the server went down. Okay, so it can go get those information which you pass from multiple data source and store in a vector, and it give you the complete information in a very readable format using a large language model. Okay, and why we need a cognitive searches, it's very, you can use it open source, you can store in a text file also, you can use that embedding output in your list and array also, but the moment the data grows a lot, that's where the cognitive search come into the picture. You can store it, and you have multiple option like refresh the refresh the index, rather than doing this over and over and again. If you're using a flat file, you need to do it over and over and again. But if you're using a powerful tool like a cognitive search vector, cognitive search enabling the vector one, you can refresh it. Okay, that's additional advantage.
Yep. Thank you. Thank you for the explanation, Ayyanar. Any more questions? Hey, hi, Vamsi. Okay. Final call to ask the questions. I think we're good. Let's call for a wrap, Ayyanar. What say?
Thank you. Thanks for session.
Thank you.
Thanks for
Thank you,
joining the
everyone.
session. Thanks for the opportunity.
Thank you. Thank
Connect
you so
again.
much,
Bye.
Ayyanar. Yeah.